It's space weather! Looking at the sun at 94 angstroms. Sunspot 2733. Consumer tip about this wavelength. What makes 94 angstroms special? It takes images every 2 seconds instead of every 10 seconds in a reduced field of view in order to look at flares in more detail. I'll let that be a lesson to you. Here are your magnetic lines in 304 angstroms. And these are still showing anomalous data. So let's just look at the 304 angstroms animation here, as there is missing data galore in the geospace and magnetosphere models. Before we get into the weeds of that, we would like to direct you to our own YouTube page, youtube.com/smashomash. If you haven't checked it out yet, please do so. The reason we're here is because we've got a new officially endorsed channel. So in addition to Sky Scholar, Suspicious Observers, Adapt 2030, David Lapointe, Tony Heller, Thunderbolts Project, Starman, and The Electric View, we've got a new one, Maverick Star Reloaded. They're looking at the pole shift situation, very, very in-depth models of the Earth's geomagnetic fields. And they just released a video 14 hours ago that we've yet to view. Let's watch a clip. Here's a little clip. We'll be watching the full video later after we upload our own.
Dwindling hectares, I think. Guys, our planet's changing, and we take it for granted sometimes because of the inertia in which it actually changes is very slow. But if you compare, in the UK 20 years ago and 25 and 30 years ago, what the climate was like and the seasons was like, then you wouldn't be able to compare what they are today.
Now, we're looking at his geomagnetic models here, and we notice that we've got essentially two north poles, and the south pole is shifting way up toward this area. We see this every day on our geospace perturbations maps, and what this guy's saying pretty much falls in line with what we're saying. So check it out, Maverick Star Reloaded. We'll have a link on our own channel. Also, they've got a website, poleshiftnews.com. Please check that out as well, as the implications of geomagnetic pole shifts and pole flips are, well, serious is an understatement. So, before we get mired down in a giant quagmire swamp of quicksand missing data, let's look at some stuff on spaceweathernews.com. You can see the X-ray activity has gone back to a flatline state despite there being sunspots on the solar disk. Looking at the ACE and Discover, we do see a couple coronal hole connections here. Here's another one, but they look short-lived. We also see fluctuations in the solar wind, so let's see, in the past day, the solar wind density has dropped down to below 10, and the solar wind speed is picking up. So that's something to keep an eye on. Expecting some geomagnetic storm conditions coming in from a coronal hole wind stream. See some very steep magnetometer movement here. See that area right there. And we are approaching another crossing of the heliospheric current sheet, which we will show you. This could accelerate and cause some serious magnetometer perturbations. You see the KP index has gone up to 3 and now it's back to 2. Here's your Cygnets forecast, which has been updated now. We'll just let that play through. You can see this is calling for another heliospheric current sheet crossing as well, as we just forecasted. Now, this coronal hole wind stream that we're just getting the leading edge of now is causing another one of these electron deficits, as you see here. Standard issue coronal hole wind stream stuff. No significant charging hazards yet, although a little bit starting to come in. And the F2 layer is not as anomalous as it was yesterday. In fact, not even as anomalous as it was a couple hours ago. And there's your aurora forecasts. And now let's get into some missing data. Here's the magnetosphere movies. First one's the velocity. Please note the time here. When it gets to about 8 o'clock, we've got about an hour of missing data there on all of the magnetosphere and geospace perturbations movies. What happened, University of Michigan? We're getting a low velocity zone there at the end of the movie. We'll let that play through and then we'll move on. Some very low velocity. Here's the density. Also exhibiting the exact same period of lost data between about 8 and 9. Looks like between about 8 and 9:20 UTC. There's your density movie. And here's the pressure, also showing the same missing data. Let that play through one time in its entirety. So you'll at least see what is there. And we will now stop complaining about what's not. And now we're going to go right back to complaining about missing data, as the geospace perturbations maps all show the same missing data. We'll let it play through. Same exact period of time. And this one's a little bit more disturbing because of the global magnetic pulses that we see associated with the missing data. Let's bring that back so you see that happen again. There was a global magnetic pulse that just happened. It basically came out of New York. I mean, you can't really see it right. It looks like it's centered in this area. Let's let that play through again. So I'm not sure what went wrong with the model. Here's the global scale of the exact same thing. The magnetic field's just spilling over the whole planet. It's still doing it, by the way. And there's that global pulse. It's not even really centered anywhere, honestly. But we don't have all the data, so here's what it looks like from the poles. Not good. Not sure why it's not there. Moving on. Since we're in the realm of magnetism, next let's look at the Gong 2 data. Keep in mind this is an hour and 27 minutes old. The Earth's magnetic field is approaching this rift right here. And this could suddenly jump across here at any point. And when it does so, there's going to be a huge magnetometer spike. This area right here is extremely magnetically active. It's pulsing around. It's shrinking this field. So anything could happen in the next 24 hours with this. Perhaps this is already the source of the ground magnetic perturbations that we see. But when this orange line snaps across to this side, there's going to be a spike in the magnetometer for sure, and a changing of the polarity. Now we'll let this play through so you can see how this field is acting. Watch this field right here. There's a lot going on there. And right now, we have a pretty weak connection that's just starting to open up. And the difference between this bunched up area and this straighter area here is the reason for the perturbations on the GOES magnetometer. Moving on. Quick shout out to spaceweather.com, the original space weather site that I started following in about 2002. Nice job, spaceweather.com. And the 10.7 centimeter radio flux is now up to 71. 1 megawatt higher than it was yesterday. Cheers. Next, let's look at the total electron content forecast. We don't always follow this one, but let's follow it anyway. Just to give you an idea of how the electrons kind of rain down, causing things like GPS navigation errors. And you can see a spike on the South Atlantic anomaly, right in this area on the corner of South America there. And a little bit of an anomaly near Papua New Guinea also. Now let's look at earthquakes and volcanoes. So quakes.globalincidentmap.com. Looking at the last 12 hours here. The 3.3 at depth in Puerto Rico. A couple of deep quakes in Alaska and Dominican Republic. Peru a 4.3. .5 in Big Lake, Alaska. 4.3 in Peru. 5.1 in New Zealand. And it looks like that's the biggest quake of note over that period of time. Here's a quick volcano rundown. Volcanoes today at volcanodiscovery.com. Shivaluch with a 15,000 foot ash plume. Sakurajima with a some sort of volcanic ash emissions. Mount Manam in Papua New Guinea. 40,000 foot high impact eruption underway. There's an uptick for you. No photos of Manam. Looks like it's shrouded in clouds. Also Ducona with a 7,000 foot ash plume. Popocatépetl. Eruption reported. Fuego, 20,000 foot ash plume. Sabancaya, sporadic puffs of volcanic ash. Blanchon Petaroa, unable to detect. And Michael of the British South Sandwich Islands, volcanic ash advisory. Although unable to detect. Moving on. Now we got a lot of tabs open. We're going to try to get through these links as quickly as possible here. Going to just show you the cosmic ray situation as we do daily. Athens showing an uptick in cosmic rays, although in the past day, a slight downtick. Trend over the last 10 days, definitely up. Here's Mexico City, also showing a similar uptrend in the last 10 days. Here's Moscow. Big uptrend at Moscow as well. Oulu showing an uptrend as well, just not as steep. DOMC Antarctica. Not really an uptrend there, although DOMB will agree. Looks very similar to Oulu. Let's look at some transients real quick. Here's Sagittarius A star, the galactic core of the Milky Way galaxy. The highest recent activity happened right before New Year, as we can see there. Highest activity ever on this scale, at least, was around 2011. Also right around the New Year. Perhaps a coincidence, perhaps not. We'll leave links to every site we visit, by the way. Also, let's look at Cygnus X1, the very famous massive radio source, bet on by Stephen Hawking and Carl Sagan. We see this has upticked recently, just since the new year. So keeping an eye on that. By the way, this is the Burst Alert Telescope, which studies transients of hundreds and hundreds and hundreds of radio sources. Next, let's look at Cygnus X3, otherwise known as the star Deneb. Massive X-ray binary. Some call it a blazar. Call it whatever you want, just not late for dinner. By the way, the largest transient we ever got from there was right around 2009, which is right around the cosmic ray maximum ever measured on Earth. So if you want to follow that, we'll have a link also for that. Next, let's look at, this is Cygnus A, massive radio galaxy, and one of the strongest radio sources, if not the strongest radio source in the known universe. Here we can see a whole bunch of transients. And let's see, looks like the most powerful one from this came in 2006, right here. Most recently, not really an uptick, just kind of at a level, solid state there. Next, let's look at 3C273. Well, what the hell is 3C273, you ask? Well, 3C273 is the brightest known quasar. This quasar is so bright that it's estimated to have a luminosity of 4 trillion times the luminosity of the sun at visible wavelengths, and they're guessing it to be somewhere between 800 million and 1 billion solar masses. It does have a large-scale jet, and I believe this is the jet right here. One of the jets. Looks like the right thing, although don't quote me on it. These are the polar jets that come out of all of these sorts of objects, including our very own yellow dwarf known as the Sun. Anyway, here are the transients of the brightest quasar known. And it looks like the most powerful transient we saw from that came in the year 2012. Maybe the Mayans were looking at it. Let's look at another massive radio source, our galactic neighbor, the Andromeda Galaxy, otherwise known as M31. We're going to do a zoom in here. By the way, if you're on Facebook, check out facebook.com/entropybusters. We made our logo from the central core area of this galaxy. So once we get all the way zoomed in here, this is going to be an artist's rendition, but it is taken from real measurements. We know there's a giant loop of more normal stars, and right at the core, a giant group of supermassive blue giants like Deneb, rotating around this massive radio source, some in a period of only days. And that's what's going on at the core of the Andromeda Galaxy. If you didn't see anything weird today, well, now you have. We will leave links to that crazy video, by the way. Now let's look at an article on Universe Today. What is going on Mars? These are called slope streaks. It looks like maybe water, some kind of liquid running downhill. They seem to start up here in a more concentrated thing, and then they come down and they kind of separate out. They look a little bit like Lichtenberg patterns. Interesting article and debate on what's causing them. Is it some kind of dry action? Is it some kind of wet action? Read the article. You won't know, and neither will the author. Next, we've got an article on phys.org about the Large Magellanic Cloud. Check it out. Little satellite galaxy of the Milky Way seems to have picked up its pace making stars. Another interesting article for you. Here's a graph. By the way, this is the heavy elements. It's very, very ugly. It looks like somebody was playing an Atari game on top of the Large Magellanic Cloud. And here's a graph of how the Milky Way is declining star formation and the Large Magellanic Cloud's increasing star formation. Is it because of the electromagnetic field reactions between the Milky Way galaxy and the Large Magellanic Cloud? Probably. Is it because of gravitational accretion? Let's do a killer close-up of the sunspot in 171 angstroms. Check it out. And here's a rising region. Will it be upgraded to a sunspot? We may never know. Although in a day or two, we probably will know. So anyway, thanks for watching. Thanks, subscribers. Please don't forget to like and subscribe. Check out our featured channels, as we said. And we'll be doing it all again tomorrow, God willing. So, when you're staring at the sun in 171 angstroms, don't drink. And if you drink, don't drive. And if you like yourself, just don't drive. Just do yourself a favor, and me, and don't drive.